a next-generation floating city weighing over 150,000 tons departs. Remarkably, only a tiny fraction of this colossal height rests beneath the waterline. To construct it, engineers must assemble massive prefabricated blocks inside a dry dock. Beneath the passenger suites lies an intricate, multi-story network of advanced machinery. This monumental vessel represents a supreme triumph of modern naval architecture. Every line of the hull is engineered to reduce water resistance dramatically.
Beneath the waterline, a massive bulbous bow creates a counterwave, helping reduce wave-making resistance and fuel consumption over the ship's operating life.
Supercomputers calculate stability metrics to ensure the vessel survives the worst storms.
A massive power plant at the bottom generates electricity for the entire ship.
These dual-fuel engines burn liquefied natural gas to dramatically reduce emission levels.
Steerable electric podded propulsion units beneath the stern replace traditional rudders completely. Every ship construction officially begins with the traditional laying of the keel.
Modern megaships are built in modular blocks, manufactured separately before final assembly. Pre-outfitting each block with utilities before assembly saves thousands of construction hours.
Engineers plan every weld and pipe run within a massive digital database.
To build thousands of luxury cabins, engineers utilize an advanced off-site factory.
Scaling these vessels to hold thousands of passengers demands advanced marine engineering.
Every layout decision must balance the distribution of weight across 20 decks.
Keeping the heavy machinery low keeps the center of gravity safely positioned.
High-tensile, corrosion-resistant steel plates form the foundational structure of the entire ship. Supercomputers run fluid dynamic models to optimize every curve of the hull.
A double-bottom keel structure is engineered to withstand groundings and severe impacts.
Finite element analysis allows engineers to predict and isolate structural vibrations completely.
Every incoming steel plate is scanned ultrasonically to detect internal microscopic cracks.
Industrial magnetic cranes transport these heavy sheets across specialized automated cutting bays.
Naval architects simulate occupant evacuation routes to maximize safety during emergency events. Wind aerodynamic testing shapes the upper decks to deflect exhaust away from passengers. Advanced calculations ensure complex ballast tank networks maintain the ship's perfect trim. The massive superstructure is divided into isolated fire zones designed for containment.
Once finalized, these highly detailed blueprints are transferred directly to the shipyard floor. High-speed plasma cutting gantries slice through raw marine steel with extreme precision. Automated welding lines join flat sheets to create colossal multi-ton steel panels. Vertical stiffeners and web frames are added, transforming flat panels into 3D blocks. Every completed block is scanned with laser metrology to verify absolute alignment. Pre-outfitting allows pipe fitters to easily install heavy manifolds inside open blocks. Massive ventilation and climate control networks are integrated before final block assembly. Miles of standardized cable trays are installed to carry power and communication wiring. Each block undergoes sandblasting and epoxy coating to prevent marine salt corrosion. Viscoelastic acoustic dampening pads are bonded to decks to reduce metal vibrations. Automated orbital TIG welding guarantees high-pressure pipe welds never leak. Pneumatic and hydrostatic pressure tests verify the integrity of all block piping. Engineers construct heavy reinforced steel foundations to support 300-ton generator engines. Mineral wool insulation is mounted on every wall for thermal and acoustic isolation. Once fully certified, the finished block is transported to the dry dock. A dedicated factory produces prefabricated cabins on a highly efficient assembly line. Cabin construction begins by securing wall elements onto a prefabricated composite bathroom floor.
These modular cabins are completely finished with luxury interiors before leaving the factory.
Insulation is fitted into wall cavities to meet specified acoustic and safety standards. Pre-engineered wiring harnesses are routed through conduits to a centralized junction box.
Robotic systems assist in tiling bathroom modules before manual quality inspections occur.
Built-in furniture and luxury fixtures are integrated and secured to withstand sea movements. Before leaving the factory, every cabin undergoes testing of its integrated utilities.
Laser metrology scans the exterior, verifying the cabin is within exact design tolerances. To protect the interiors, the finished cabin is wrapped in weatherproof film.
Flatbed trucks transport the sealed cabin modules directly to the shipyard wet-quay. Staged at the shipyard, the cabins await insertion as hull assembly continues. Inside the massive dry dock basin, the colossal ship hull takes shape.
Hydraulic alignment jacks compress block joints, verifying fit-up targets with millimeter accuracy.
The massive gantry-crane lifts pre-assembled superstructure modules directly onto upper decks. A colossal 300-ton dual-fuel generator is rigged directly into the keel framing. Under the stern, steerable potted propulsion units are bolted to heavy steering bearings.
Active stabilizer fins are installed in the hull pockets, designed to significantly reduce vessel roll under suitable operating conditions.
Radiographic non-destructive testing is performed on critical hull welds to verify joint integrity.
Watertight boundaries are inspected using specialized vacuum box testing, while a low-friction silicone coating is applied.
Seawater slowly floods the dry dock, floating the completed steel hull for first time. The dry dock gate floats away, opening a clear berth channel to the ocean. The dry dock gate is slowly lowered and floated away, establishing a clear berth channel between the covered dock and the deep water basin. Moored securely at the outfitting quay, the hull is stabilized for final staging. The wet dock is transformed into a highly coordinated workspace for thousands of workers.
The engine's crankshaft is coupled to a high-voltage alternator, completing the power chain.
Transverse tunnel bow thrusters are fitted, designed to assist in maneuvering restricted waters.
Waste heat recovery boilers capture energy from engine exhaust to heat freshwater systems.
Engineers leave temporary side openings in the hull, allowing flexible modular cabin insertion. Rigid lifting frames and telescopic pallets slide each finished cabin smoothly through the opening. Workers glide the cabin along temporary tracks, sliding it onto vibration-damping mounts. Standardized plug-and-play connectors and flexible braided hoses isolate the cabin plumbing from vibrations. Corridor wall panels seal the cabins, transforming raw decks into a luxury hotel. Beyond modular cabins, artisans build massive public atriums, theaters, and restaurants.
Desalination systems combine reverse osmosis and evaporators to generate massive quantities of fresh water. Advanced onboard wastewater treatment systems process black and gray water to meet applicable international discharge standards before release where permitted.
The navigation bridge integrates radar, satellite charts, and autopilot into one central console.
Specialized low-drag silicone coatings are applied, reducing friction and fuel consumption. Sea trials begin with full-power propulsion runs, verifying maximum design speed performance.
During steering trials, the steerable propulsion pods are tested for maximum maneuvering agility.
The crash stop trial evaluates emergency deceleration, reversing the pods to halt the vessel.
Blackout trials simulate complete power failures, proving emergency backup generators restore safety power. Navigation and communication systems undergo rigorous testing to ensure absolute reliability in open waters.
Sound and vibration sensors verify staterooms remain quiet and comfortable during high-speed transit.
What began as raw steel has become one of the most complex machines ever built. Behind this floating city lies an extraordinary story of engineering, precision, and human ingenuity.